So this is going to be a brief video lesson on section 9.5, which deals with essentially factoring. This should be an easy section, so hopefully I won't have many problems here, but here goes. The first thing we're going to learn in factoring is the zero product property. And this is what it looks like. Let's say I have two variables, a times b, being set to 0. Now you don't know what a or b is, but you know that the sum, so a times b equals 0. So either a or b has to be 0, because 0 times b is 0, or a times 0 is 0. So there is no other combination of numbers when multiplied together gives you 0. Either a or b has to be 0. So in this case you can safely say that either a is 0 or b is 0. They can both be 0, but at least one of them has to equal to a 0 in order for this to be true. Now that being said, we can apply this to a slightly more intricate case. So for example, I have x times x minus 1 equals to 0. Same rules apply. Either the x or the x minus 1, the binomial, has to be a 0 for the sum of them to be a 0. Because if x is a 0, 0 times this will be a 0. And if the outcome of the x minus 1 is a 0, then that times the x will be a 0. So either the x has to be a 0, or the x minus 1 has to be a 0. The only difference with this versus this is that you have to do a little bit of solving here, because you have to solve for x, and you add 1 to both sides. So plus 1, which of course gives you x equals to 1. So for the second case, for this case, x can either be, again, or, x can either be 0, so if x is a 0 over here, it'll turn this entire thing into a 0 because you'll distribute 0 to everything. And if x is a 1, you'll have 1 minus 1, which is a 0. 0 times x is a 0. So either one of those has to be 0 or 1 in order for this statement to be true. So let's do another quick example here. Let's say I have 2x times, I don't know, 4x minus or plus 6 equals to 0. Same rule applies. Either the 2x or the 4x plus 6 has to equal to 0 in order for this statement to be true. So once again, you can say that either the 2x is 0 or the 4x plus 6 is 0. Well, now all you have to do is solve for the x over here. All you have to do is divide by 2, and 0 divided by anything is still a 0. So over here x equals to 0, and over here I'm first going to subtract 6 from both sides, which gives me 4x equals to a negative 6, and then I'm going to divide everything by a 4, which then gives me x equals to negative 3 over 2. So in this particular statement, x either has to be a 0, which if plugged in here would make this entire statement to a 0, or x has to be a negative 3 over 2, which when plugged into over here will make this statement 0, because 4 times negative 3 over 2 makes it into a negative 6. Negative 6 plus 6, 0. So in the last example for the zero product property, because that's what we're talking about right now, is a zero product property. I'll write it here, so it's the zero product property, is this case. For example, we have x minus 4 times x plus 2 equals to a 0. Just like the previous three cases, either this binomial or this binomial has to be a 0 for the statement to be true. So either the x minus 4 has to come out to be a 0, or the x plus 2 has to come out to be 0. So we set those statements just like that. Either x minus 4 has to be a 0, or the x plus 2 is a 0. Now that's done. All you have to do is do a quick solution. Plus 4 here to both sides, plus minus 2 here to both sides. And we get x is either 4 or x is negative 2. They can't be both. X has to be one or the other. But if x is 4 here, you'll get 4 minus 4, which is 0. Turns everything into a 0. And over here, if x is a negative 2, it'll turn this into a 0, which in turn turns everything else into a 0. So these would be your two possibilities that will make this particular statement true because of the zero product property. Alright, so that was the first part of 9.5. Now let's talk about factoring. For us to factor, you first have to remember what the GCF was. The greatest common factor. The greatest common factor is the largest number that will go or divide into two relationships you're looking at. For example, let's look at 18 and 27. So if I ask you to find the greatest common factor between 18 and 27, you have to find the largest number that will go or divide into both of those evenly. No fractions or decimals. So 9 is the largest number. 9 is the GCF. 9 goes into 18, 9 goes into 27, and nothing larger will. So 9 is the GCF for there. And if I were to factor this out, the GCF goes on the outside. And what's left, 9 divided by 18 is 2. 9 divided by 27 is 3. If I were to factor these two out, that's what it would look like. The GCF goes on the outside on the left, and what's left goes inside the parenthesis. Because if I were to distribute the 9 back out, I would get 9 times 2, 18. 9 times 3 is 27. The same thing works for variables. So if I'm to find the GCF for, let's say, x to the 5th and x to the 2nd. So I'm asked to find the GCF here. So what is the largest variable power that goes into both of those? In case of variables, it's always easy. The smaller power is going to be essentially the GCF, because x squared goes into x squared. X squared also goes into x to the 5th. So my GCF is going to be x squared. So if I were to factor out an x squared, over here, x to the 5th divided by x squared gives me just an x to the 3rd. And here, x squared divided by x squared, well, that's just a 1. So that would be my factored out for. And again, if I were to distribute this back in, I would get x squared times x to the 3rd, which is x to the 5th. X squared times 1, x squared. So I would get my original statement back. Alright, good. So let's see where this leads us. So let's say I have a problem like that, and they're asking us to solve this equation by factoring. What they want us to do is find the GCF of these two and factor it out that way, and then use the zero product property to tell us what are the two possible solutions to this problem. Well, to factor this out, I first have to find the GCF between the two of them, and the GCF for this particular problem will be 2 for the constant, because 2 goes into 2, 2 goes into 8, and for the variables, the largest power will be just x to the first power. So my GCF is just 2x. That's the largest value that will go into both of these evenly. So now that that's done, I'm going to factor out my GCS. It's going to go outside. And 2x squared divided by 2x was just an x. 8x divided by 2x was just a 4. All equals to 0. So I factored it out. Now remember the zero product property rule. In this case, if 2x times x plus 4 equals to 0, either the 2x has to be a 0, or the x plus 4 has to be a 0. So all I have to do now is divide the statement by 2, and in here I have to subtract 4 from both sides. So I'll get x is 0 or x is -4. So those are my two possible solutions. And the only thing different from the zero product property problems is that I had to factor it out first. Factor, then set it to equal to 0 and just individually solve them and get your two solutions. Now you might have a problem like this where they give you 6x squared minus 15x and they ask you to find the roots. What does that mean? All it means is set this problem equal to 0 and give them the two possibilities. That's it. When they ask you to find the roots and they're not setting it to 0, they're asking you to set it to 0 and then give them the two solutions. In this case, the only thing that you have to do first is factor it out. So find the GCF. The GCF for the constants, the largest constant that goes into both 6 and 15 will be 3. And the largest variable that goes into both x to the first power and x squared is x to the first power. So it's going to be 3x. That's my GCF. So the GCF goes outside when we factor. And what's left goes inside. 6x squared divided by 3x. Well, it's going to give us just 2x. Negative 15x divided by 3x. That's going to give us just a -5. All equals to 0. Then to find my two roots, I'm going to set 3x equals to 0. And I'm going to set my 2x minus 5 equals to a 0. If I divide both sides by by 3 here, so I divide left side by 3, right side by 3, x is going to be 0. So that's my first possibility. That's easy. Over here, if I add 5 to both sides, I'll get 2x equals to 5. And then if I divide both sides by 2, I'll get x equals to 5 over 2. So that's my second solution, or second possibility. So if I were to plug in either x into the original equation or 5 over 2 into the original equation, I would get 0 as the final outcome of the statement. So these are my two roots, my two possibilities, my two solutions. So thank you very much. If you have any other questions, refer to either the homework video or see me in class. Thank you.